Quadratic equations come in many different forms. Some don't have an x term at all, just an x squared term and a number. And we've seen already that we can solve them easily by the square root method. As soon as we take the square root of both sides, we can see our two answers, our two values for x. Another kind of quadratic equation has an x term, like the 4x here, and it's also factorable, even if it doesn't look like it at first. In that case, we move the number to make the equation look factorable, and we get a 0 on the other side at the same time. That 0 is useful because as soon as we factor, we know that at least one of the expressions in parentheses must equal 0 because we get a 0 when we multiply them together. Either x minus 7 must equal 0, or x plus 3 must equal 0, or both. If we test, we'll find that in this case, both answers are correct. Then there are the other quadratic equations which have x terms but are not factorable. In that case, we make the equation factorable. We make it a perfect square. And then we use method number 1 to solve it by taking the square root of both sides. How do we complete the square? First, we move the number that doesn't work, -2, over to the other side to make room for a number that will work when we add it to both sides of the equation. How do we find that magic number? We take the coefficient of the x term, here it's 6, divide it by 2, that gives us 3, and square the result. 3 squared is 9. Adding this magic number, positive 9 in this case, to both sides gives us a perfect square on the left. We factor it, and then take the square root of both sides to get our final answer, exactly as we did in the first method we saw. You might want to review some of the modules on solving quadratic equations if you had trouble with any of this. In particular, completing the square can get pretty complicated, and there will be times when you wish you had an alternative, another method for doing the same thing. Good news, you do. You can solve a quadratic equation simply by following a formula, provided you have your equation in standard form to begin with. You already know the standard form, something x squared and something x and something, where the three somethings written here as a, b, and c are real numbers. For example, in this equation, a is 2, b is 5, and c is -7. You'll notice that any of them can be either positive or negative. Clear enough? Good. You can prove that it is by rewriting this one in standard form and labeling exactly what A, B, and C would be in this case. I want the entire equation on the left and a 0 on the right. And I want all of it in the correct order, like this. Now that I have it in standard form, I can simply read off from left to right. A is 3, B is -5, C is -7. Very important, because the formula for solving a quadratic equation uses, guess what, A and B and C. If I can recognize A, B, and C correctly and substitute them in the formula, I can get the solutions instantly. I say solutions, more than one, because that plus or minus sign is going to give us two different statements in the answer. A moment ago, we solved this problem by completing the square. Now let's do it by substituting A, B, and C into the formula, and then compare the results. We have the values for A, B, and C. We check the formula. Wherever we see an A, we write 1 instead. For B, we write 6, and for C, a -2. And that's our answer, the value of X. But it's too complicated. It doesn't look like our earlier, simpler answer yet. So let's use some of the techniques from the module on square roots and see how simple we can make it. We simplify the square root of 44 by using the multiplication rule. And if you study that result closely, you'll find that the square root of 4, which is 2 of course, makes it possible to factor and rewrite the numerator without changing its value. Then the 2's on top and bottom cancel out to give us exactly the same answer we got earlier by completing the square. Now let me point out something you already know. Simplifying all that algebra isn't very simple. It can be plenty hard. That's why we carry 4 different methods in our toolbox, so we can be lazy. Pick the easiest one and use it. But if none of the other 3 methods work, then plug in your quadratic formula, substitute for A, B, and C, and start pushing all that algebra around to get the simplest possible answer. Try it now on this one. I start by checking for standard form. This one already has it. So I look for A, B, and C and write them down so I can't make a mistake. With the formula right in front of me, I look for A and substitute 3. Look for B and substitute -5. And for C, I put a -7. Now that's my answer. The only question is, can I make it any simpler? A little bit, by multiplying it out. But then I have to stop and settle for a fractional answer in its positive and negative forms. So, it works. But what's it good for? Among many other things, word problems. Joyce and George are in Hawaii. They could be doing something useful like surfing, but instead they choose to write postcards to all their friends. Either one could do the job alone. In that case, it would take George 3 hours longer than it would take Joyce. George is not your heavy-duty postcard writer. But instead, they both blow the whole day by doing it together in 7 hours. Question: how long would it take George alone? How long would it take Joyce alone? You've done this kind of rate of work problem before. To get started, do two things. First, make X the time Joyce would take by herself. Second, look closely at what each of them does in 1 hour. Don't try to do the whole problem right now. Just see if you can write down the equation that describes the problem. Then come back. What I really want to find out is how much the two of them do together in 1 hour. That's a method that I know works in these problems. So first, I find out what Joyce does in 1 hour. That's 1 over x. And then what George does. He's slower. 1 over x plus 3. So what do they do together in 1 hour? What she does plus what he does. That's all there is. And that's 1 over x plus 1 over x plus 3. Now, we already know how long the whole job takes them together. 7 hours sitting in their hotel room when they should be on the beach. So how much of the job do they do in 1 hour? 1/7. And notice that so far we've stated how much they did in 1 hour 2 different ways. Now we put the two together and we have our equation. It looks a little unmanageable at first because of all the fractions, but I'll just go ahead and multiply to get the LCD and then use it as is. When I multiply both sides by the LCD, it looks messy until I cancel out and come up with a much neater equation. But, surprise, it's a quadratic equation and it still needs solving. So go ahead and do that now by any method you choose. Then come back and set your answer. The equation doesn't seem to factor, so I'm going to use the quadratic formula. I'll need my A, B, and C, and the formula itself. From there on, just as before, it's all substitution, and then simplification, until I get my two answers involving square roots. I want to go even farther than that, so I use a calculator to find the two numerical answers to the equation, positive and negative. I ignore the negative answer, even though it does solve the equation, because I know that Joyce needs a positive amount of time to do the job alone. How long? 12.66 hours, because that's the positive value of x. How long would George have taken to do the whole job? X plus 3 hours, or 12.66 plus 3 hours, 15 hours and 40 minutes, long enough to ruin anyone's vacation. Don't worry about the negative answer we had to discard in this case. When you do word problems, common sense comes first. You have to pick an answer that fits the actual problem. These problems can be hard. If you're looking for more information, you'll find it in your textbook. You'll also need more practice problems to work with until you feel confident about this kind of problem. Find the right pages in the same book and you'll have plenty to work with. Dig in right away, and don't worry, they'll get easier as you go along. Good luck.